Okay.
Kato lang ko ang miss na ko itong
Amp kaya po na siya. What should def amp nga sa operational amplifier po? Of course, the def amp is, or differential amplifier is the first stage in our operational amplifier. So we have here parameters. Gamay or mabasa ra?
Mabasa ra.
Okay, so we have here parameters of differential amplifier. So we have input characteristics. So assuming perfect symmetry in a differential amplifier is a good approximation for many applications, but in precision applications, we can no longer treat the two halves of a differential amplifier as identical. There are three characteristics on a data sheet of every op-amp that a designer uses when more accurate answers are needed. They are the input bias current, input offset current, and the input offset voltage. Okay, so in this part class, we are talking about the parameters na makita na to sa atuang data sheet. Okay, so we have the input bias current. Okay, so we are on the topic characteristic ng tanawon sa ato ang designer for every op-amp nga data sheet. So we have input bias current. So the inputs to an op-amp requires some amount of DC biasing current for the transistors in a differential amplifier. So the input bias current is defined as the average of the two DC base currents. So we have input bias I for current. That's how you name it. Nayo bang libro na line name anak. Okay, but for me mas possible siya basahon input bias current. So average we have IB1 plus IB2 all over 2 bias current, input bias currents is typically in nanoampere. Typically, pwede po siya class na micro kung hindi siya possible in nano. Okay? So for example, if we have IB1 of 85 and IB2 of 75, 85 plus 75 divided by 2 is 180. This means that when no signal is applied, the inputs of an op-amp, that is our differential amplifier, will draw a DC current of 80 microampere. The fact that both transistors in a differential amplifier require an input biasing current leads to the following operating restriction. Okay? Ang gimina ni first class is, di ba, we have an amplifier, for example. This is our negative, positive. We have our input here. We also have our input here. Diba, nakatay yung mga input? Input 1, input 2. Right? So, any of the two as tayo mamutangan o signal. But in this case, when no signal is applied, okay, kung wala yung signal masunod sa itong amplifier class, okay, this input bias current will be needed para mas musod siya. Okay? Bisag walay signal class, inside our amplifier, hindi naman na siya dependent always with the signal. Okay, naman sa na pagtuyok. Diba, naman na ila. What's it doing? Naman na sila ilahang parameters na before sudlan ni mong signal, nag-operate na sa ilahang. Okay? So for this time, the input bias current is drawn to our amplifier kung walay signal either nilang duha. There will be input 1 and there will be input 2. So for here, we have an operating restriction. Okay, nag-draw man siya og input biasing current class. Okay, bisag walay signal, so naa siya operating restriction. an op-amp will not work if either of its input is open. For example, naka-ground ang usa. Okay? Open ang usa pag yun.
Miss, forward bias ng DC, Miss. No?
Yes. Forward bias, reverse bias. DC is direct current. Okay, there are two types of currents. We have the forward,
DC,
two
AC.
types of biasing current. Forward bias and reverse bias. Ito, this is just direct current. Hindi siya yung forward siya or reverse. Okay. So, for example, naniha, ang usa grounded, ang usa open. Okay? Now, the op-amp will not work if either of its input is open. Okay? Given that one input is grounded. Kung usa ka input is open siya, yung usa grounded, sakot, wala mo sa amplifier. Okay? So, for example, wala yung natag figure, pero wala siya. For example, in the figure, the non-inverting input is shown to have an open between op-amp and the ground. So, this is our non-inverting input, right? The positive one. For the negative, that's the inverting input. So, ingon ta ha, the non-inverting input is shown to have an open siya. May connection. Open between the op-amp and the ground. So, this open circuit would not allow the DC biasing current required for the operation of the differential amplifier. Hindi siya associated. Okay, grounded siya usa. So, since the differential amplifier Since the differential amplifier would not work, the overall op-amp circuit would not work. Grounded ang usa, open pa din ang usa. Hindi mo sulod. Thus, an input biasing current path must always be provided for both op-amp circuits. So, dapat ang kita mo class, kung grounded ang usa, dapat close ni siya, mahal ang grounded. Para naikagian atong input biasing current. Okay? Now, we have the next parameter. We have the input offset current. Ideally, the two input biasing currents are equal because they are assumingly perfectly matched. And thus, their difference is zero. Since match man sila, the difference is zero. In a practical operational amplifier, however, the biasing currents are not exactly equal. So, the input offset current is the difference of the input bias currents expressed as an absolute value, given that you assume IB1 or IB2 is greater with each other. Okay, may ang question na IB1 is greater than IB2, then therefore, the value of your base current 1 is greater than your base current 2. Okay, now, para di ka maglibog to solve the input offset current, you just need to insert the absolute value. Kung baba mo ha.
Katong fabs.
Shift ups.
Shift hubs eh.
Yes. Shift ups. Shift yung ups kay nasa left part button sa yung value. Yes. Shift up. Kung sa'yo. Hype ba? Hype. Up. Shift ups. Ganon. Shift. Hype. Na meaning absolute na siya. Or basically, you just need to input ninyo muna ang pinakadako sa pinakagamay. Or kung hindi nyo ganahan, mag-isip mo muna, labi ng naka-notation. We have here absolute yan, so that's for the input offset current. Next. Okay, so our base current i-minus yan. Assuming this one, IB1 is greater than our IB2. Now, if IB2 is greater than our IB1, then si IB2 mag-plus, si IB1 mag-minus. Wow! Plus,
So kami sa kung IB1 ang greater
kung
mo na.
si, as gi-assume na to, nga si IB1 ang dako kaysa ni IB2, then plus na siya.
Plus,
Si IB2 may minus. Now, if si IB2 ang assume nga greater than IB1, then this is plus, this is minus. Okay? Si plus, adto magpuyog sa dako ang i-assume. I-assume nga dako rather. Okay? Next, we have the input offset voltage. Okay? So, the input offset voltage is defined as the input voltage that would produce the same output error voltage and a perfect differential amplifier. So, we have two equations here. Okay? We have input offset voltage. We have output offset voltage all over our differential gain. Okay? Differential gain na siya class. Or, with respect to our voltage, error voltage and voltage gain. Okay, that's only the differential gain. Muna siya formula class. Kung wala gihatag si output offset voltage, gihatag si error voltage, na po gihatag na gain, okay? Gain is unitless man. Okay, may na ninyo. For output offset voltage, yung naihatag na VIO or the output offset voltage or input, output offset voltage is equal to. Okay? Now, we're done with parameters na tanaw niya, tanaw sa designer sa tuwan sheet. This time, we have parameters, okay, of differential amplifier or operational amplifier due to mismatch of transistor. So our discussion on differential amplifier has been based on the assumption that the transistors are perfectly matched. That is, they have exactly the same electrical characteristic. Okay? Perfectly matched sila duha. In practice, this cannot happen. Wala perfect sa tinuod ng kinabuhi. There will always be some difference between the characteristics of the two transistors. This leads us to the following two parameters of VA, the output offset voltage and the input offset current. Now, input offset current, ma-mention na po siya direct class. Kaya usa na siya sa parameter na makita po na mismatching of transistor. Katupod si input offset current na nasa baba mo po ito usa sa pinaka-importante ng parameter na naon sa atong designer sa atong datasheet. So basically, input offset current is a parameter that is both mura siya negative o positive. Negative siya kay it is a defect due to mismatching. Positive siya kay because of that mismatching na siya gihatag ng parameter, and this parameter can be used, okay, importantly be used sa ato ang data sheet. Okay? Okay. Output offset voltage, even though the transistors in a differential amplifier are very closely matched, there are some difference in their electrical characteristics. One of these differences is found in the values of VPE for the two transistors. So when VPE is not equal to VPE1, it's not equal to VPE2, an imbalance is created in the differential amplifier. The DA or the op-amp may show some voltage at the output even when the voltage applied between two terminals is zero. This is called the output offset voltage. Now, note that when the inputs of the DA are grounded, so grounded to siya class, hindi na siya open. Diba mo sa inyo grounded? Okay. So when the two inputs of this term differential amplifier is grounded, okay, correction, zero. The output shows a measurable voltage. Diba, naiinita na kung ideally match ang usa ka amplifier, right? Duha ka transistor so usa ka amplifier. Dapat wala sila'y measurable voltage. It's supposed to be zero. Diba? Perfectly matched man dapat si siya. But, ningon siya dire, walay input gibutang, walay signal gibutang, isaksak, walay signal gisod sa atong amplifier. Pagpagawa sa atong output na siya noticeable, measurable voltage. Okay? So, this causes one of the transistors to conduct harder than the other. Nag-cause yun, nag-result na siya sa imbalance on the differential amplifier. Okay? So, kung wala input, dapat wala output. Right? Now, since wala input din na inigawas nga output, kaya na ako man nagsulod ng mga differential amplifier, matakabaw. Right? So, this should have o mag-cause din siya o imbalance sa next amp. Right? Now, what if nani siya feedback ni samot? Okay, this is a feedback. Feedback. Imong gibalik. Okay? Now, kung feedback na siya class, this is our R. Okay? Kung feedback na siya, ibig ang katong nga input 0, 0, pag among dili na 0.11111. Gibalik og feed. When there is supposed to be no signal, ni imbalance. Samot pag output diri ni sunod ko diri samot kay imbalance sa tong system. Kuha. Mo na class, na dyan yung feedback sa garan ang common amplifier. Okay. Which causes one of the transistors to conduct harder than the other. So wala man siya kabaw. Uy, friend, asa may mas naku na tundo ka? Ikaw, ako. Okay? Kaya mukandak ko ni mas mukandak ko ni mo or ikaw may mas mukandak na ako. Right? Hindi naman sila equal. Hindi naman sila magka-communicate. Right? They cannot communicate with each other. So ang meaning, ang mahitabo, mag-compete sila asay mukandak nila. Kaya ilang tumong is dapat mapaandar nila ang amplifier. Okay? Huwag sila na yung muna. Okay? Brainwash naman sila nga. Dapat pandaron ako siya. Sige, huwag ilan buhat pandaron. Kaya kung siya nga input, sige, pandaron po na ako. Wala, sige, andar. Wala communication, meaning, maglumbaanay sila o pandar. They are not perfectly matched man. Okay? Now, there are several methods that may be used to eliminate output offset voltage. One of these is to apply an input offset voltage for the between the terminals of VA so as to make output 0. So we can use this formula class. Okay? The output offset is equal to our VIO multiplied with our gain. Okay? That's our Vout offset or output offset voltage. Next, we have the input offset current. Must i-explain niya siya dire kung sa detail niya with respect to the mismatching. So, naingon siya, when the output offset voltage of a differential amplifier is eliminated, voltahin ha, there will be a slight difference between the input currents of the non-inverting and inverting inputs of the device. Of course, so V is equals to IR. If there is changes, imbalance between our voltage, there is also a slight changes with our current because they are directly proportional to each other. Diba? V is equals to IR. Kung na mo sa TV, samot na mo sa I. Okay? Coil na sila, not unless they are inversely proportional. Next. This slight difference in input currents is called input offset current and is caused by beta mismatch between a transistor and a differential amplifier. Now, if we go back during our electronics, a BJT is a beta-dependent transistor. BJT man natin ang amplifier. Nakakihatag diha. For example, di ba, ang first ang gihatag sa discussion is naka-BJT siya. Okay. So, BJT is a beta-dependent transistor, meaning they are temperature dependent. Okay? Kung saan yun sa temperature dependent piece? Temperature dependent class meaning na siya changes sa magdepende siya sa changes sa ato ang pag-dope. doping, balik taog, fundamentals. Okay? So for doping, di ba natay formula ni beta? Di ba kinundong mo yung formula?
Ketong
IC
tulo,
is
miss.
equals to beta IB. Right? Beta can be solved IC over IB. IB should be the smallest, IC is the highest, and IE moderately. So, diba? Bila ko to. Moderately, huwag ko sa'yo. Okay? That's how you solve beta. Okay? And these beta, these currents are also temperature dependent. Okay? Kung naay dili indot ang imong pagkado, inay changes sa imong temperature. Okay? Because they are temperature dependent. Si beta is temperature dependent. Beta means your dependent sa temperature between the di ba naman tayo ionization? Diba? Pinamdum mo ni ionization. Okay? That's electronics first discussion. Okay. Next. Asa na tayo? Okay. The difference in the base currents indicates how closely matched the transistors are. If the transistors are identical, the input offset current is 0 or must be 0 because both base currents will be equal. But in practice, the two transistors are different and the two base currents are not equal. Mucho na siya class. Mumito ng ipanganak na, for example, na ay transistor mismatch. We have also impedance mismatch. Okay? Muna nabuhay na sila sa impedance matching o transistor matching. Okay? That is, wala naman na sa inyo ha. Fortunately, that's circuits 3, electronics 2 and 3. Okay? Diha class, during our time, ang discussion na is, tagaan may usa ka circuit, transistor, naka-AC and DC, then i-trace na siya kung asa siya sa iyo. Okay, asa siya nag-mismatch, tagaan may for example, for impedance. Ang tagaan may daw ang impedances, that is a circuit, tagaan may impedances, then among i-calculate ang dapat yung impedance na yaha. If lower, higher, then we must do impedance matching. Impedance matching, diha mo correlate si capacitor kaya naman siya AC. Capacitor, we have resistors, we have transistors. Okay? Mag-jumble na class, hindi mo pa nakunanakon si transistor. Okay? Hindi pa dyan nakunanakon si resistor, si reactance, inductance of si capacitance. Okay? Diha, mag-jumble na ng class. Fortunately, wala mo siguro kita. Okay? Fortunately. Okay. So we have here examples. Okay. A differential amplifier with a 15 volt voltage at common collector has a beta of 80 to 100 from left to right. So, ato na siya visualize. Okay? You know how to draw this first sentence? Class? Class. Are you still with me? Or are you with me in the first place?
Gasunod na miss, makapayong miss.
Okay. So how to visualize class? So di ba, naman tayong aning circuit.
Padaganan ba nag-feedback miss ng pag-visual na?
No. It's the general amplifier.
NPN.
Yes, this is NPN. Okay. Okay, dapat iba mo visualize na. Okay. Now, ningon mo siya. The differential amplifier is with a 15 volts voltage at common collector. Voltage at common collector.
DCC.
Asa na si BCC?
Taas.
Taas. Pila na? 15. Positive. Ningon man si previous discussion, previous na ni ay, that the intensity intensity of our VCC is very much the same with the intensity of our VEE. Ganit lang negative siya. Right? So this is negative 15 volts VEE. Okay? This is 500k ohms. Ako lang ihatag-hatag. Okay? Do we need to have another parameters? Characteristics? Okay?
Ang
So,
Betamax.
si input offset current.
Itong formula sa
Input offset current.
IB.
Saan po si input offset current?
Input offset is equals to IB1 minus IB2.
IB2.
Absolute.
How about the input bias current?
Input bias current is equals to IB1 plus IB2 over 2.
Over 2. So we need to have this IB1, IB2. Assuming IB1 is higher or bigger than our IB2. Okay? So, kung saan pag-solve si IB1?
IB1 is equals to input bias plus input offset over 2.
Okay. Now, do we have input offset? Wala yung
Wala,
yata.
miss.
Diba?
Mga pangita, miss.
Yeah. IB1 can be solved using, ako na gihatod ba?
BBE.
Oh. IB1 class, di ba na may gibutang na rin formula ganina? Saan mo to?
IB1,
IC is beta IB.
BIB.
Right?
Then
Find IB,
B
we need to
I-
have IC,
over IE.
IC over beta. Divide
Yes, miss.
si IB.
Yes, miss.
Si IB wala itong kuhaan, hindi si IC, hindi si beta. Si IB ang kuhaan. You divide the whole equation or both sides of the equation with beta. Beta. Eh si IB dapat na ito ipabilin.
Yes, miss.
So IB is equal to IC over beta. Right? So IC is very much equal to our IE. This IE is the IE of our transistor, each transistor. So meaning IE1 or IE2. Now, in our amplifier, naman tayo IE diri class, napo tayo IE. Pagpadong nila diha na tayo IT. Inatawag o tail current. Right? How do we solve tail current? VEE minus VBE
Plus
all over
BCC.
RE.
9 today.
Kung mag-loop ka diri,
Ay, almost 2.
right? Looping. Sige, loop na po. But this is the formula kung mag-review mo ba rin. Okay? Now we have RE of 500K. Right? Kung makuha na to si IT, kung saan pagkuha si IE1, IE2, you just divide it by 2 para makuha niyo sila tagsa-tagsa. Kaya i-add niyo na ng luha, siya ra sa IT average. Hello, are you still with me? Okay. So we need to solve, inani ka magtorno sa class. For example, missing sa input offset current. Ilista din na ko tanan on-site formula ni input offset current. Na kung naay given, muna akong gamiton. Kung walay given, ako na silang pang cancelon. Walay given niya nani, walay given niya nani. Yan ang kainundong ko ay, formula mani. Formula. Yan si IC equal ni IE. Yung sunod, wala may IE. Ano sa'yo formula ni IE? Si IE gikan ni IT. Tanaw ko ka sa diagram. Kung si IE, asa man si IE? IE can be solved through looping. Kung dili ka iko si loop, naatay IT. Problema sa pag-solve si IT. Mo to minumduhan na po na ako sa pag-solve si IT, which is kanina. Tingnan ako, given pa tanan para makuha si IT. Natay BE, natay BBE, nay RE. Masolve na si IT. Right? Inana ko class, reverse engineering. Reverse engineering tawag na.
Miss, di ba makuha bang BBA, Miss, no? Gamit lang sa beta?
BB is constant. That's 0.7.
Oh.
Diba? Now, let's try to
Wala
solve.
na ron ni Vince at Vince.
B is 15.
Ang nalaman sa exam.
BB is 0.7. All over 500K. Wala yung kung calculate.
Mahal lang ang medyo.
Thank you, darlings.
0.0286 service.
0.0286.
Notation. Eng. 48.6. 28?
MB.
Ilang? Micro, nano?
MB with micro, Miss.
Micro.
Ay,
Times 10 to the negative 6.
6.
Asa daw?
Milli, milliampere.
minus 0.7 over 5.
28.6 micro. Okay, you divide it by 2.
14.3.
This is 14.3 micro. Right? We already have our IP 1 and 2. So, masolve na to si IP 1 and 2. IB1 should be equal to IE1 all over beta 1, which is equal to 14.3 micro divided by 80. They give you 80. From left to right, ingon man siya. So, ang beta dire is 80. Beta dire is 100 ba na?
100.
Okay? So, this is phase 1. Yan eh. Ano mo?
3 microampere over.
Punta ninyo. 14.3 times 10 to the negative 6 divided by 80.
Deep. Na hindi.
Ilan notation? Ikondong,
Egg.
micro or nano? Micro is 0. Pinag-group.
17.8.
Nano. Nano lang siya. Negative 9. Times 10 to the negative 9. Oh. Oh. 178.
Paano ko hindi pa?
179 lang. 0.179. And IP2 is equal to IE2 over beta 2. We have 14.3 micro all over 100. 100. 143.
9.
Depende kung sa'yo ikaw sa...
Nano, Miss No? 143. Nano?
Nano? Di ba? Nano?
Ito na.
Ang negative na yun.
Times 10 to the negative 10 to the negative 6 all over 100.
Nano, miss. 143 nano.
143 na.
143 na.
Sakto. Okay. 143 nano. Times 10 to the negative 9, nano na siya. Are you all familiar already with the notation?
Yes, miss. Mini, micro, nano, deca.
Okay. So we can solve this too. Absolute value of 0.179 nano minus 143 nano equal to pila? Absolute. Shift 5, shift 5.
0.036 nano ampere.
Sige.
0.036 36 nano ampere.
0.036.
036. Ay,
142. Ay, 143 kaya. 143
nano.
nano. 143 nano, miss.
142.82 nano.
42.82 nano ampere.
What's? Dahil hindi ko. Hindi.
Okay. So this is our input offset
Value.
current.
Ay, correct.
Now, our input bias current, i-divide lang ng 2 class.
Hindi yung sigara.
71.41 ampere.
Ah,
Okay.
71.41. 71.41 nano ampere.
142.82 times 10 to the negative 9 divided by 2.
71.41 nano ampere.
Okay, 71.41 nanoampere. Okay, so mo ni siya ay solution. Class, kung maingon siya, neglect BPE. Ikaw yung mag-solve. Balik mo silunan.
Balik.
Kasi labot.
neglect, miss. Blanco, miss. Wala eh. Wala ating BBE.
Zero si BPE. Isolve mo na ninyo. Hindi naman ako.
Okay. Kami na kuhan, miss. Malahi ang formula kay wala kuhan.
No, dili ang formula. Ang value.
Okay.
Okay? So, narin na, neglect or include. Next, find the values of two base currents given input offset current is 50, input bias current is 110. Assume that IV1 is greater than IV2.
IB1, so plus, miss. Then IB2 kay minus.
IV1
IB1 is equals to input bias current plus input offset current.
Input bias.
Input bias current plus input offset current over 2.
plus minus 2 lang. Okay. Aura ginana pa sa whichever is bigger. So, since bigger man si IV1, plus B mag-plus na. Pila yung input bias? 50
50.
plus 110 all over 210 ba na?
110 ang input bias.
Bali.
110
110 plus
plus 25. 135.
135 nano ampere. Amperes. 135 nano amperes.
IV2
110 minus
85.
25.
85 nano
85.
ampere.
Nano.
85, 95.
85, miss.
Oh,
Sure?
85.
85.
Ay, 95 pa.
85.
Kay Juan man.
Di na tayo bang mumatan?
95 miss. Kay 100 may.
25 na eh.
100 minus 15.
Oh, 85.
85 is
That's all right. Dapat na 120 yung tato para kuhan.
Skip po lang kayo awal. Hindi na awal. Yes, that means consensus class. Even during board exams, sa imong karatol, 1+1, ito, keep mo ginan. Yes. Yes, naman instances na din na.
Miss, sa mga miss kay ang
Walang
mga
point.
1.
Plus 1 is 1. If both are
Okay.
then
Ay,
both
sorry.
zero.
Okay, ganap ka na. Okay. Kuha na.
Kuha na.
Okay. Now, na yung mga instances class na ingon siya nga. So, base resistance or input
RB.
resistance.
RB.
Okay? So, for example, input, natay input ring RP. Nga given si input offset current o si input offset voltage o si input offset current. So
Saan is Ohm's law?
basically, input offset voltage
Over 8. Kuhan ko rin.
offset current. Dapat same sila kapilido. Dili pwede nga naka-output ang usa. Yan taps. Ang usa in, ang usa out.
Kuhan sa daan ng kuhan miss, ang magkapareha ay kuhan palitan ko.
Kung given na sila duha, you can directly substitute na values.
Pero-
Kung dili given na la.
Kung kuhan miss, ang
Kung
given miss ka.
naka-output ka nito sa class, si voltage output po.
Ay,
Dapat same sila kapilido.
regardless na siya sa kuhan miss sa RB.
Basta input. Kung input, kung output, walang day, output na RP. Okay? Output resistance na to is somewhat here.
RE.
Right? Or depende kung sa i-name niya sa itong output resistance. Kasagaran dyan class is input resistance iya RB, RS.
RS.
Yes.
Naku, VR miss.
That one. Okay? I will post your activity. No.
Dili lang dong.
Say question ko? Ay.
0.4.
No, di ba? Gusto na matalo ko ng ano?
Converting mo ang saan i-divide mo, di ba nakamay ko siya? I-convert mo ito na, dapat times 1,000.
I-calculate. Dili ko i-calculate na ko.
179.
Sige, kaya na.
Pwede na.
Micro. Micro mo siya.
Bird, lagay sa psoriasis bird.
Oo. 28.6 micro.
Kaya kung wala, hindi ko likod sa psoriasis. Today.
Dapat
Normal akong
sige lang, regardless of naka-micro siya, kung sa ihatag nila, that's still the value. Di ay?
Oo, no.
Isa kakalkyo na.
Kung kalkyo miss, once again na, hindi mo nasuot. Ano miss, kasi
Ala, ikaw kayo.
Anak, pilay ka ganito, pilay ka. 178. Ako yung kalkyo ato?
Ay, kasi na Joanna.
miss, pagsuot na malisin yan.
Oh, okay. Sorry.
Kasi ka Joanna.
sa marker.
Ano may bird na may
Sila yung opposite.
Oh, lahat ako pa, lahat kita.
Picture ko yun.
Oo, para ma-resolve din yung data.
Gawa ko tulog ko eh. Tulog ko. Sa'yo kayo maging mata niya. Kuha na kayo sa tungkol sa limit ng klase. Oo. Alas 5.
Micro to kanina ko. Gusto what? Micro ba ta?
Grabe sakit.
Ah.